for Year 11 Specialist. Please keep in mind that this is my first ever online video, so hopefully there aren't too many errors. I will go faster than I would in a normal classroom because you can obviously pause and rewind and watch things over and over, and obviously you can send through any questions that you have regarding this at the end. So our topic today is position and direction vectors, which are particular types of vectors that we're going to start using. So a position vector is a vector that's given relative to a fixed point. So that concept of relative is important. All right, we'll come back to that in a minute. So they're similar to coordinates. So if I was to show the position vector OA and OB on a set of axes, we would draw our coordinate axes just as we normally would. Always label the origin as O, and then we can go ahead and do our points. So obviously A is going to be 3 across, 4 up, and B is going to be 2 to the left, 3 up. So when we're talking about the position, what we're actually saying is the actual point. So this point here for A, and this point here for B. Okay. Between those, so now that we've stated position vectors, then we find the direction vector. So we want to find if I was to travel from A to B, so that order is important. So from A to B is important. If it was BA, we'd be going the other way. So we want to find starting from A and going towards B, what direction would we be going in? So to find that out, so I would recommend drawing this and making sure you've got your arrows right. I'll just erase my pen so you can see the arrows again. So obviously because we want to end up at B, we can see that we would have to take the negative of A, so we're going nose to tail. So we want AB is going to be negative OA and positive OB. So notice the notation that we use. So O means starting at the origin going to A, starting at the origin going to B, and we want to end up with starting at A going to B. This is when we find this kind of notation handy because obviously we're going to add our I components and then add our J components. And then finally we get the direction AB is -5, -1. So in terms of what you're familiar with, when we used to use plotting points on the coordinate axes and doing linear equations, things like that, you would think of position vectors as a point, like the coordinate points, and direction vectors is like the gradient. So it shows the direction. So it's not about the relativity to a fixed point. It's only about saying what is its direction. So we can obviously find parallel, perpendicular, things like that. So again, see how DC is also the same direction. It doesn't matter that it doesn't start at A. It's still the direction vector. Okay, so AB can also be defined as CD or EF. All right, next one, we're going to show that position vectors OA, OB, OC, and OD form a parallelogram. So obviously we're going to start by plotting all of those points. If you were doing something like this, you obviously want to try and be as accurate as you can with your drawings, just so you can kind of see what it would look like. Obviously we're going to prove with other matters like what the sides are going to be, but when you're starting out, you want to actually make sure your drawing represents as close as possible what you're trying to see. So let's start with just our position vectors. So starting from our origin again, so we've got A, B, C, and D. So a little tricky to see at the beginning. A parallelogram will connect the sides, so we know it's going to look something like that. So now to prove that it's going to be a parallelogram, we need to know what a parallelogram's features are. So we know that we're going to have opposite pairs of parallel sides. So theoretically, the AD and BC should be the same, and the DC and the AB should be the same. So one way to do this is to show, as I said, those two sides are the same. So if they are the same direction, they will be parallel. So when we're starting off with proofs, it's a good idea, rather than having to write OA, OB, OC, OD, let's make our life easier and just say A, B, C, D. Remember what we talked about, making sure you're using that notation of either doing the arrow above or underlining to show that we are looking at vectors, not variables. So we can see AB is negative A plus B. When we put the values from our given position vectors, we have AB is going to equal 4, negative 2. Do the same with DC, and we can see that DC also equals 4, negative 2. So we've done 2 of the sides, now we just do the other 2, so DA is 2 over 4, CB is also 2 over 4. So because we have proven that we have 2 sides with the same directions, we know that ABCD is also a parallelogram. Okay. If we were to prove this further, we would obviously look at things like the angles in between, and we could find magnitudes to find the lengths. All right, but today we've done what we need to do and show that it's a parallelogram. You can stop the video here and have a go at the first few questions in 4C. So please do questions 1, 2, 3, 4 on graph paper and do them to scale. And then you can go onwards with 5, 7, 8 and 10. And there are also some great examples in the textbook that you can go on with as well. So please pause the video and do those ones first before watching the rest of the notes. So hopefully you have done those examples, excuse me, as I asked. All right, we're going to look at just a couple more examples and looking at just slightly different notation. So notice how rather than writing OC, we can also write this R. So remember how I talked about before how we'd say it's relative to the origin? So that's what that R stands for. We're saying relative to the origin, we have point A. Relative to the origin, we have point B. And we want to find relative to the origin, point C, which is the same thing. It still just means OC, but you can obviously see it's just a quicker way of writing it. So we can put the same information, just given in a slightly different way. So we want to use our position vector A and position vector B, and the fact that AC, the direction vector, is 9i plus 15j, we want to find the position vector of OC and then BC. So let's look at what we've got. So we've got our position vector A, position vector B, and we're told AC is 9a plus 15j. So to work backwards and find what our relative to the origin C must be, we know that it must be OA plus AC, so make sure you agree with the nose to tail, so O to A to C, and then we want to find the position. So all we have to do is add those two together, and we get our position vector of C is 12, 14. BC now we can find, and again make sure you agree, so to go from B to C, we want to make sure that we've got negative B plus C to get our nose to tail. Add them together and we work out that BC is 610. Now, our next part is to say, are A, B, C collinear? So hopefully you've come across that word collinear before. So that means all on the same line. So what we're trying to determine is we can see A and C are both on this line, and we worked out B and C were on the same line, but did it actually happen that B also somehow ended up here? That's what we're trying to prove. So the way that we can show that is we work out what AC is, and with the way we've rearrange that is just to take out a multiple. We've taken out a multiple of BC, and we can see that it's the same direction, because as we know in gradients, we can simplify to work out when we're going in the same direction. So we've got AC can actually be 3 lots of 3 over 5, and BC can be 2 lots of 3 over 5. So they're going in the same direction. So by showing that, and we also know that they both contain point C, that means they must all be on the same line. All right, so we can redraw that to show that BC does in fact, OB does in fact make it onto that line. All right, example 4. OA is 5, -6, and OB is -310, so find AB. So obviously as we become more proficient, we don't always have to draw diagrams. You can try and jump straight to the working. So hopefully you're starting to recognize what is happening whenever we find AB. It will be -A, +B. Find our values. And obviously I recommend, if you are still having trouble, do draw a diagram, but we're trying to get to that point where if we can, just doing the algebra. So now we're going to find C, given that it's situated on AB in such that the ratio AC-CB is 1:3. So if you go back to the question we were just looking at, where we were trying to work out if A, B, C were collinear, what we could say is, well, how far along the line AC is B? So similar kind of concept. So the way that we're going to do that, now let's have a look at what the picture is going to be. So we're saying if we've got A and B, and we want to find where C is, so that it's in the ratio of 1:3. So OC, this one here, again, think about what you're going to have. So OC is obviously going to be OA plus some multiple of AB. We know that it's situated as a ratio of 1:3, so it means from A to C is 1 part, and C to B is 3 parts. So that must mean it's going to be 1/4. Oops, sorry, went too fast. So we can see that OC position, so the position vector of OC is 3, -2. Okay, so this represents 1/4 of the distance, and then this would be the other 3/4. Now we're going to say on the same question, given D is I plus 2j, prove B, A, B, D are collinear. So again, showing that they're on the same line. So AD is -5, -6 plus 1/2. So AD is -4, 8. Again, to prove they're collinear, we're looking for the same direction. So think about what the direction of AB was, and that was -8, 16. We want to somehow rearrange this. We want to somehow rearrange AD so it looks like it's got the same multiple as AB. So AB was -8, 16. So we know half of that will be the same. So we can see that AD is half AB. So we can see that because they have the same direction, just a different multiple, same direction, different multiple, then they are in fact collinear. They're going in the same direction. Okay. All right, so that should be enough now, guys, to finish you off on 4C. Again, if you have any questions about any of the concepts, please feel free to email me, or you could comment on the video if you do have a quick question about one of the slides, because there may be people with the same question as you. Otherwise, enjoy, and I'll post the next video soon. Thanks.